Welcome to another presentation on Autodesk Revit MEP 2012. My name is Tom Cassell. I am an MEP technical specialist with MicroCAD training and consulting, and this presentation is an introduction to how lighting, power, and circuiting are handled within Revit MEP 2012. The focus of this is for the electrical discipline and to explain how Revit can best help the electrical discipline make the transition into BIM using Revit MEP. Let's start with a brief introduction into Revit and how it is different than AutoCAD. Revit is not a 2D program where you're drawing lines, arcs, and circles that will represent light fixtures. You're not putting a rectangle in that's going to represent a panel or panel schedules that are made with text and lines. Revit is a database-driven, object-driven program. In other words, in Revit, we're going to do things like place light fixtures, which are very similar to AutoCAD blocks. However, they're 3D and they have a lot of intelligence to them. Building information modeling, the key to building information modeling, especially for electrical, involves the information. And the information in the electrical discipline, mainly circuiting and loads, is a big part of what an electrical engineer needs to handle. What Revit does is it takes these objects, these blocks, and it gives them a bunch of smart information. So a brief start to what we'll be showing in a little while is in Revit MEP, when I want to place a light fixture, I'm placing a light fixture. I'm not placing a rectangle. That light fixture has information. Now Revit is database driven, and so when we add this information to the model and we go look at that, this model now knows that it has a light fixture that's a troffer light, and it knows that it's a 277 volt fixture with a load of 160. If we look further into the properties of it, not only does it know that, but in the long run it'll eventually know the panel and circuit number it's on. We can also adjust the apparent load depending on what model light we're putting in, depends on how much the load is, the number of lamps, the voltage, or even if I scroll down just a little bit, the photometrics of this file. So as a lighting designer, this program can be very beneficial to you as well because it can give you average illuminance for a room. We can attach wattages, luminous flux, and illuminance. So different engineering information can be applied to these fixtures. And as they are, and then dropped into the file gains that information and stores it in the database, making it transferable to the circuits, to the panels, to anything else that we need, to the spaces. So one of the most powerful parts of Revit is the fact that after we add these light fixtures and put them on the circuits, the panel will automatically update with the loads for those light fixtures, and we'll see this coming up. If I change out the light fixtures and choose different light fixtures, the panel will automatically update, making it easier for me to check for overloaded circuits. Because Revit MEP is model driven, let's show you an example of what the 3D file looks like currently. You're not working in 4 or 5 separate files for separate floors. You're not working in divided Excel spreadsheets and DWGs and trying to make sure that the count in your Excel file matches the count of lights in your DWG. In Revit, it's all tied into a single model. So when you add light fixtures to the 3rd floor, if your panels are all sitting in the basement, that's not an issue as it is in AutoCAD MEP. That's not an issue as far as schedule counts. So I add 10 new lights to my 3rd floor, I need to go make sure that my schedule or Excel file is updated. That doesn't need to happen in Revit MEP. And the reason why is because Revit MEP is a solid database. So you add 10 lights to the 3rd floor and the database updates with 10 more lights. Now it makes it quicker and easier to get a complete count of light types that are being used. as you can see in this example, in multidiscipline firms, you can also see that my lights are being placed around a lot of mechanical equipment, plumbing equipment, pipes, conduit, cable tray, and other fixtures that can get in the way. So we can actually run coordination reviews as well to make sure our lights aren't hitting any other objects that they may encounter in a ceiling grid, such as sprinkler heads or air terminals. Now, going back to the lighting plan, what we can do is we will start by laying out light fixtures. Now, I've already created the panels for this. I did this ahead of time to save a little bit of time. I will show you the properties of the panel in a few minutes, but we'll start by laying out light fixtures. So to start in this room, we're going to start with placing light fixtures. Now, the light fixtures that you're going to see in Revit MEP are smart in a lot of ways, as I mentioned earlier. And to start, I'm going to use the troffer light that I already have available. However, in a little while, we'll also talk about other light fixtures that are available. And I have a 2x4 4-lamp 277 volt light fixture right here ready to use. Now, this light fixture wants to host to the architectural ceiling grid that the architect's given us. Now, this is going to help us out in quite a number of ways. One, by hosting your light fixtures to the architect's ceiling grid, if the architect later on makes a change to this ceiling grid, such as changing elevation of a ceiling grid or changing the layout of the grid itself, we'll instantly be able to see those changes with our lights. Now, if the architect moves their ceiling grid up or down, what I want to show is that this light is hosted specifically to the elevation of that ceiling grid. So any change the architect makes in the future in ceiling grid heights is not a concern of ours. Our lights will automatically move with it. What we can do now is look at the lights and take a look at the properties of them. So I'll grab this 277 volt light. Here's all the properties of that light. And I want to start by pointing out that most of the properties of these lights in Revit MEP are parametric. In other words, the lamp type that's here, if that's not really the lamp type that's being used, it is completely customizable. So we can make a change. If I needed to get a new 120 volt light that's very similar to this, even the voltages are adjustable, the number of poles, if this is a 2-pole light, and other information is all completely editable. So placing fixtures is very simple. That's really all there is to it. It's very similar to placing blocks in AutoCAD. It's quick, it's easy, but the part that's really going to save a lot of time is the fact that I can now take these lights, and as I mentioned, my panels may be in the basement. Now, they may be on the first floor. I don't know where they are, but it doesn't matter. As long as they're somewhere in the model, I can take these lights and create a circuit for them. When I create that circuit, you get the ability to say, yep, all of these lights are on the same circuit with this junction. Oh, that's not for these lights, but with LP1. What happens is these lights now go on LP1 automatically, and it only shows you panels here that are available for 277 volt circuiting. In other words, it's not going to give you any of your power panels because all your power panels are meant for 120 volt for this. Properties that you have available here, the circuit number is grayed out. We don't have the ability right here to make an adjustment to that, and we'll see why. So it automatically assigned it the next available circuit. We can change the load name. We can adjust the frame or the rating of this circuit or the wire types that are going to be used on this circuit. So I can say this is THWN wire. If I do, it's going to say I need 12 gauge wire. I need 1 hot, 1 ground, 1 neutral. And the total load on this circuit is 960. So all that was automatically calculated for us. Now I know it's simple numbers when you're only talking about 6 lights, but imagine all this stuff being automatically calculated for you over the course of a whole building. The time it saves to not have to do that little calculation. The last piece of information that it figures out for you automatically is the wire run. It knows the distance that it needs for wire to connect all these lights over to the main panel, which is actually on the other side of this building. So it knows there's 296 feet worth of wire, and it is calculating voltage drop over that. So we have a 1.98 volt drop over the length of this wire based on 12 gauge wire. I have warnings set up to where if that exceeds a certain amount, and I think I have it set to exceed 2 volts, to give me a warning saying this isn't going to work. All we have to do now is finish that circuit. We'll take the other room and we'll put it on the next circuit. So we'll create another power circuit, again showing how fast it is to do this. Put it on LP1 as well, and a 0.83 volt drop, 10 gauge wire. Let's put it on THWN, 12 gauge wire, 308 feet because this is a little further away. Since we have a higher gauge wire, it's going to be a slightly higher voltage drop. Let's finish that as well. So now that these are circuited, we'll go look at the panel in just a minute. But this light has a lot of information to it. Next we'll see that we'll even have the ability to go to the Annotate tab and do tag by category. I can go around now and even tag these lights with the light type. So these already know they're light type L1. I've already told them they're L1. Now I can select all these and just get my light tags and move them all into position at the same time. Take that one, make a minor adjustment to it. I can go to my floor plan now that I'm done with my ceiling plan, and you'll see that we even get the exact same lights, and I can also tag them all here. There is, by the way, a tag all feature that'll tag all lights automatically. Let's put it in the upper right hand corner, upper left hand corner where I want it. I also get the ability to tag by category and tag all these lights one more time. Except this second time I'm going to do something slightly different. I also want to know in the lower right hand corner exactly what circuit they're on, so I can change this tag to a circuit tag. I'm doing this in the room right next door, and I'll just do the circuits for this room. See how they all want to align? So they all want to sit in the same spot. Now I'll tell it it's a circuit tag. So this tells you it's circuit 41 on that exact same LP1. This is circuit 16 on LP1. Now those were the circuits that were available, so that's how it laid it out. This saves a lot of time when it comes to readjusting the panel, because we're going to see in a few minutes that as I readjust the panel, my tags are automatically going to update. Now let's come back to this. Let's take a moment, pause, and go look at the panel. Now the panels are all stored up here in the electrical room, and specifically the panel I want to look at right now is LP1. Now, to look at LP1, let's first look at the properties of LP1. Placing a panel was as quick and as easy as going to electrical equipment, choosing the panel board that I wanted, and placing it on the wall. All the information to this panel is shown over here in the properties palette, such as right now this panel has a total connected load of 220 kVA. It has a total estimated demand load of only 11 kVA based on the demand load factors that I've applied, which we haven't shown yet, and we'll cover those a little later. Scrolling down, it'll even tell you the current phase on A and the current phase on B and the current on phase C. Keep scrolling down, we'll see more information. Panel name, the mounting type, the size of the mains, and the distribution type. Now if I want to get into the panel to actually look at it, we just create a panel schedule. And I'll use the default template for this to save a little bit of time. So here we are currently. You can see I have a 42 pole panel ready to go. Different information in here is pre-filled out based on setting it up. I can tell it what it's supplied from. I can add my own notes. But the information that you see on circuit 41, the 320 on phase C, is there because it was the next available circuit. Now, readjusting your panel is typically a difficult process. It takes a lot of time. In Revit, it's as easy as can be. I really want panel what was 41. I want it to be 16. I want it to be right after the one the circuit I just laid out. So I'm going to hit move up and move up and move up, and there it is. Now it's at 17. I can move it across. Go take a look. It's at 18. I'll move it up one more. It's at 16. What you notice is it moves the loads around. So you can also see that the loads at the very bottom are readjusting. This happens automatically as you lay out lights. So you lay out lights, create circuits, and the panel automatically populates. Scrolling down a little bit, you can see that there is lighting, and then there is lighting for a dwelling unit. The lighting for a dwelling unit has a demand factor of 46.89, so the estimated demand load is a lot less than the connected demand load. However, the other lighting, which is your emergency lighting, has a slightly under a 4 kVA load and 100% demand factor. So the panel takes all this into consideration. Now it knows the total estimated demand load in currents and the total estimated demand load. So all this information is extremely useful. So some other things that we can do with this. I can now take this and hit rebalance loads, because a big problem with certain panels is that making sure that phase A, B, and C are as even as possible can be a difficult task. It can take a long time to actually get right. Now, if it's way off, that's a problem. What rebalance loads will do is it will take your panel and do the best it can to reshuffle your circuits around and make sure that phase A, B, and C are as close as possible. Now, it shuffled them around, it just didn't change all that much because we're already pretty well balanced. But when it does that, it moves all your circuits where it sees fit. For example, the room we just did, it moved to circuit 1. If I really want this to be circuit 1 and I don't want it to change, we have the ability to lock different circuits in place. So I could take all of these and lock them. You also get the ability to unlock. You can group different circuits. You can assign spares. So let's say we're never going to end up using this last one. It's going to stay a spare. So by making it a spare, I can say, no, I'll leave it called spare. My panel's now full, ready for printing. We'll show this being put onto a schedule in a little while. For the moment, let's go back and take a look at our lighting plan. As we pan back over to the room we were just in, you'll notice that instantly these two rooms changed to circuit 1 and circuit 3. That's what rebalance loads did. Now, if that's not what we wanted, we can go back to the panel and make adjustments again. But the point was, is as I readjust my panel, this happens automatically. A lot less work for the electrical engineer to do. The next optional feature I cover, and I call it optional because circuiting works with or without wires. So the fact that I can draw wires is completely optional. You don't need to draw the wires in order to get the circuit to operate correctly. I can click on wire though if I choose, and I do have my wire types where I can start my wire and just choose what wire type I'm going to create. So I'm going to create some arced wire where I will get these lights right here circuited together. You know what, I'll run these together here, and then my home run's going to run off in that direction, and so it puts my home run in. Now my wires automatically calculate their size based on the object they're connected to, and tick marks are either on, off, or calculated as well. A lot of people don't show tick marks, but you do get the ability to tag your wire as well, and I'll load a tag just for my wire. So I'll go to my electrical tags, load my wire tag, and when you do, it'll tell you that this is a tag for circuit 1. Now I can take that tag and say, you know what, I want a tag not just for circuits, but that also shows me my panels. So this will show you that Revit is customizable as well, where I can have it go ahead and put this in, get a space in there, and go ahead and let's update that so it not only shows me the panel, but it shows me the circuit number as well. So editing and making your home run tags and your wiring is really that quick and that easy. If you were to connect a multi-branch circuit, it will show you an arrowhead for each multi-branch that you have, and you can draw as many wires as you want or none at all. Again, doesn't really matter at all if you show or use wires. It's completely optional, and I know that a lot of electrical engineers at this point do not show wiring at all. And now that we've added all these devices, wires or no wires, it doesn't matter. We get the ability now to not just look at your panel schedules, but look at fixture schedules and get fixture counts as well. So I can double click on my lighting fixture schedule and show you that it automatically knows in this building that we have 42 emergency lights that are manufacturer of Lightalier with a wattage of voltage. I did not fill out the number of lamps or light types on any of my emergency lights. Now I happen to know that those are 2 lamps, and they also use T12 lights. So I have 2 options. Option 1, I can go back to my floor plan, select my emergency light, edit it, and fill out the number of lamps and the lamp type and go get all that information there. Or option 2, changes in Revit can be made anywhere, so I don't have to actually go back to my floor plan to make any of these updates. I can do it right here in the schedule, and that information transfers back to the floor plan and back to your model. So there you go. Notice now my emergency lights are already populated to type T12, and there's 2 lamps. Now this is a growing count and a growing list, so I only have L type 1. We use the same light fixture type for this entire building. I know that's not common, but that's what we did this time. So there's 214 of them. Of course, before I laid out all these lights, if I were to take all these lights in this room, minus the model, and get rid of them, and I go back to my schedule, you'll notice that my count just updated from 214 back down to 206. I undo to put those back, and I'm back up to 214. So this is going to also help out quite a bit. Think of how much time an electrical engineer spends looking at the floor plans and marking off every light to make sure your count's right. Because if your count's off, not only are your schedules off for ordering the lights, but your circuiting is most likely off as well, because you have too many lights calculated into your circuits or too few calculated into your circuits, which could mean that you've overloaded a circuit that you don't realize you've overloaded. None of that happens in Revit because it's parametric. It's automatic. And the information is just consistent from the model to the schedules, either panel schedules or quantity schedules. And the last feature that I would like to show includes printing. At the end of every project, a program would be completely useless if you weren't able to print. So Revit has sheets built in, so I can take this and make a new sheet, where this new sheet comes in partly populated, where I can say, you know what, MicroCAD will be the owner. This is an elementary school that we are working on. And this is going to be my first floor lighting plan. Right, we can go and fill out all the rest of this information as well, but what I care about is that this is E101 for my first floor lighting plan. And what you'll see is that placing the lighting plan on the sheet is just drag and drop. Now we're going to drag and drop this in, and we're going to realize that it doesn't fit. So the lighting plan doesn't happen to fit on this sheet. Now this is the largest sheet size we have available. So we have a few options. Either one, we can use match lines, break this up into little individual models. Or two, we can simply readjust the scale of the view to 330 seconds, and now it fits. Whatever works best for the project is what needs to be done, but it's a real quick change that happens automatically. Now, something I want you to notice that happened automatically is I want you to pay attention to these tags for just a minute. I changed the scale of this view to say 1/2 inch equals a foot, something that'll be drastic. What happens to all my tags? All your annotation in Revit is annotative, and what that means is it's set to be on the screen at printed size, and what it does is it takes this scale that we choose and it automatically resizes the text based on that scale. So this is how big that text needs to be in order to print 330 seconds high at a 330 seconds inch equals a foot scale. So there it is on the sheet, and I guarantee you all that text is at perfect height. So again, another thing you don't have to consider in Revit. Let's make a second sheet for a moment. And you're going to realize when I go to make the second sheet that the next sheet, Revit automatically knows that this is MicroCAD. This is an elementary school, and we're going to call this electrical schedules. Won't be specifically panel schedules, but it'll be electrical schedules, and my electrical schedules will start in the 600s. A lot of this information will instantly populate from sheet to sheet. Things like the sheet name would obviously be different from sheet to sheet, so Revit handles that accordingly. If I take my schedules and I want to see LP1 on here, it's just drag and drop, and it comes in onto my sheet organized and set up exactly the way I had it organized and set up when I set it up back in the schedule. If I want to see my light fixture schedule on that same sheet, it's just drag and drop, and there's my light fixture schedule. Minor adjustments will make it look perfect. Now if I wanted to see this with things like center justified, I had that option back when I set up my schedule. I had options for formatting, for line weight, for line type. All of that was available. You can make these look any way you want them to look for printing, so it's just up to you to do that when it gets set up. It's not difficult to do, but because everybody has their different standards, Revit is flexible to meet all those standards. I'd like to thank you for attending this introduction to lighting, power, and circuiting in Autodesk Revit MEP 2012. This presentation is meant to hopefully give a brief introduction as to what Revit MEP can do for the electrical discipline. However, if there are further questions or anything that wasn't answered in this presentation, we would be happy to assist you if you just call the office at 617-923-0500 and just let us know. We'll put together a customized presentation for you and your company to show you exactly what it can do for your specific needs. Look for future videos on conduit and cable tray, as well as other disciplines, plumbing, mechanical HVAC, and mechanical piping. Thank you. Have a good day.